All right, this is 10.1, the first one. Sequences. Question number one, write the first four terms of the sequence. Given a subscript n equals 3n minus 2. That's simply a formula, made up formula, but they're telling us that the nth term equals 3n minus 2. So the first term would be a subscript 1. Everywhere you have an n, plug in a 1. So, and then do the arithmetic. 3 minus 2 equals 1. So the first term is 1. Second term. Now, everywhere you have an n, plug in a 2. 3 times 2 is 6, minus 2 is 4. A subscript 3, that means the third term. And then the fourth term. So, what are the first four terms of this sequence? 1, 4, 7, 10. Part B, same idea, they just gave a little bit different formula. First term, everywhere you have an n, plug in a 1. So we have negative 1 to the first power over 2 times 1 minus 1. So we get negative 1 over 1, which is negative 1. Second term, everywhere you have an n, plug in a 2. I'll have a positive 1 over 3. Third term, everywhere we have an n, plug in a 3. And we get negative 1/5. And now the fourth term. So our first four terms of this sequence, negative 1, positive 1/3, negative 1/5, positive 1/7. They just simply give you a formula, follow the formula. Number 2, going the other direction. Now, this turns into a little bit of a puzzle. So this is really easy if you figure out the puzzle. It's very challenging if you don't, but it's a puzzle. Write an expression for the apparent nth term, a subscript n, of each sequence. So in other words, in this case, they've told us 1, 3, 5, 7. What you need to recognize is kind of like a table. When we have n is the term. So this is the first term, this is the second term, the third term, and the fourth term. So with that in mind, when n equals 1, I want an answer of 1. When n is 2, I want an answer of 3. When n is 3, I want to get an answer of 5. And when n is 4, I want to get an answer of 7. So the trick is, what's the formula, what's the pattern that will make that happen? And if you will notice that, in this case, since I don't have anybody to ask and try to get feedback, I'm just going to tell you. But if you just took each of these values up here for n and multiply by 2 and subtract 1, you get the number below it. So 2 times 1 is 2, minus 1 is 1. 2 times 2 is 4, minus 1 is 3. 2 times 3 is 6, minus 1 is 5, and 2 times 4 is 8, minus 1 is 7. So that would be your formula for the nth term. So this excess stuff that doesn't really belong. And it's just a matter of figuring that out. Next one. Now this one looks a little trickier because it's going from positives to negatives to positives to negatives. All right, my first hint, ignore the signs. So just focus on 2, 5, 10, and 17. What will work to get me 2, 5, 10, 17? And again, if you see it, it's real easy. If you don't see it, it's going to be a little more challenging. All right. 2, 5, again, ignore the negatives. 2, 5, 10, and 17. Notice, every one of those is one more than the numbers I just wrote. 1, 4, 9, 16. And what are those? That's 1 squared, 2 squared, 3 squared, and 4 squared. So, really in this case, what it's getting is simply n squared plus 1. That will get us the 2, 5, 10, and 17. But what about the signs? Because it's not a 5, it's a negative 5. Well, anytime you have positives and negatives taking turns, come back up here, and it's going to be just like what we did right here. Negative 1 raised to a power, because when it's an odd power, it's going to be odd, even power, even. So I have negative 1 to the n. Now, if I do that, this part's still the number, but this is going to make the first term negative, the second term this part here, it's going to make the first term negative, the second term positive, etc., etc. Well, that's not what I want. I want my first term positive and the second term negative. So I just need to adjust this a little bit. What if I do something like that to it? Now, when n is 1, I'm doing negative 1 squared, which would make it positive. When n is 2, for my second term, then 2 plus 1 is 3, negative 1 cubed would be a negative. So by simply doing the n plus 1, and actually I could have done n minus 1 as well. So in this case, there's actually more than one correct answer. But it does, this is one of the answers that will suffice. Again, a little bit more complicated. Just depends on whether you recognized it or not. All right. Now, if you're trying out for my UIL math team, you've probably already done all of these things in the past. You're going, it's about time I got around to teaching them. So, my math people are in good shape with all of this. All right, so number 3, Fibonacci sequence. Fibonacci sequence is defined recursively as each term is part of the term before it. Okay. A subscript 0. So they start with that instead of 1. So A subscript 0 is 1. A subscript 1 is 1. And then after that, A subscript K will equal the term that's 2 before it plus the term right before this kth term. So, going the long way around the world. I'm going to go a long way to start with. They tell us A subscript 0 is 1. They tell us A subscript 1 is 1. So we've got that. Now, I want to find A subscript 2. So, from our formula over here, K is 2. So it's going to equal A subscript 2 minus 2 plus A subscript 2 minus 1. Everywhere I have a K, I am plugging in a 2. Now, that becomes A subscript 0 plus a subscript 1 equals, well, what was a subscript 0? That was 1. Plus, what was a subscript 1? So the second term, a subscript 2, is 2. I'm scrolling up a little high. We're still going to be using this formula as I move forward. So now I want to do a subscript 3. So everywhere there's a K, I'm plugging in a 3. So it's going to be A 3 minus 2 plus A 3 minus 1. What that really means is a subscript 1 plus a subscript 2. A1 was 1 plus A2 is what we got right there. So it's 2. So we get 3. Now, hopefully also you are recognizing now that these right here are the two right before the term we're working on. So I'm going to try to skip this a little bit. So as I move forward now, let's go to A4. It's simply going to be the 2 before it. So it's simply going to be A2 plus A3, which was 2 plus 3 from this information down here is what they equal, which gets me 5. And we wanted the first 6 terms, but we started with A0. So let me go one more here to A5. And it's going to be these two terms. So it's simply A3 plus A4. So it's going to be 3 plus 5, which gives me an answer of 8. So the answer to this problem is going to be the sequence 1, 1, 2, 3, 5, 8. And those are the first 6 terms of the Fibonacci sequence. And it also introduces you to the idea of a recursive sequence. Now, there can be all kinds of recursive sequences. There's an infinite number, you just make it up and somehow you use the terms before you. But the Fibonacci one is where it is simply adding the 2 terms before the current one. That's what makes it be Fibonacci. All right, shifting gears slightly. We'll come back to the sequences, but we got to pause for a moment and talk about factorials. Because, again, unless you're on my UIO math team, you've probably never done anything with factorials before. If n is a positive integer, n factorial is defined as, and factorial looks like an exclamation mark. So that n exclamation mark, really, we say it n factorial. It is simply n times, and then you just do the one less than that number. So n minus 1 times 1 less than that number, n minus 2 times, and you keep going down all the way until you get to 1. Now, note this one special case, 0 factorial equals 1. Just accept that and go with it. 0 factorial is not 0. 0 factorial equals 1. All right, now, so just to demonstrate what we're talking about with these, 3 factorial would simply mean 3 times number 1 less than that. 2 times number 1 less than that, and you go all the way until you get to 1. So 3 factorial is simply 3 times 2 times 1, which is 6. 5 factorial is going to be 5 times 4 times 3 times 2 times 1. and you multiply that out. Now you can do whatever you want to with it. We already know 3 times 2 times 1 is 6. That's 20. What's 20 times 6? Of course, you might have also put the 5 and 2 together and got 10 and did 10 times 12. Doesn't really matter. You're going to get the same answer of 120 every time anyway. Actually, if you're on my number sense team, you probably memorized these. All right, number 5. Find 8 factorial divided by 2 factorial, 6 factorial. All right, we are going to do this problem twice. Once the long way, and then I'm going to show you a shortcut. 8 factorial means 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. 2 factorial, 2 times 1. Now, there's nothing between the 2 factorial and the 6 factorial, so that's implied. Multiply. And then now 6 factorial. 6 times 5 times 4 times 3 times 2 times 1. And then we are definitely not going to do all the multiplication first. We're going to cancel. 1's cancel, 2's cancel, 3's, 4's, 5's, and 6's all cancel. And I would even do that. Cancels leaving 4. So really the answer is just what's 4 times 7, which is 28. Sure don't want to be doing 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. All right. But as easy as that was, there actually is an even easier way. I'm going to do the same question again. This time, 8 factorial. I'm going to write it as 8 times 7 times 6 factorial. Because that would still mean 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. But I just leave the 6 factorial there. 2 times 1 times 6 factorial. Now, just as all of those canceled, they cancel right there just as easy with a whole lot less writing. Still end up at the same place, so I still get my answer of 28. But I can get there a lot faster. And they can play all kinds of games with you. Number 6, I would recognize, again, I want to break down the bigger one. So I'm looking at matching the 6 on top with the 5 on bottom, 6 factorial with the 5 factorial. And I'm also going to match the 3 factorial with the 2 factorial. So with that in mind, I'm going to start with the 3 factorial. I'm going to write that as 3 times 2 factorial. That's going to match with the 2 factorial on top. Times and times. Now, 6 factorial, I'm going to write 6 times 5 factorial to match with the 5 factorial on bottom. And now it should be real clear that the 2 factorials, notice those are not 2's, those are 2 factorials, but I got one on top, one on bottom. 5 factorials cancel, and we are simply left with the 6 over 3, which is just simply 2. Next question. At first glance, seems a little trickier since we don't actually know what n is. Well, this is more the type of question you're going to see on your SATs. They like to do it with variables instead of specific numbers. But also, again, my UIO math team, this is the way you see it on the UIO math test. It's with variables. They usually don't put the actual numbers in there. Okay, follow the same idea we just did, though. Between n versus n minus 1, which one's the bigger number? The n is. So that's the one I am going to break down. So n factorial is n times one number less than that, which would be n minus 1 factorial. And that matches with the n minus 1 factorial on bottom. Those completely cancel. All I am left with is n. And last question, number 8. Write the first 5 terms of the sequence given by, so we're back to our sequences, and it tells us begin with n equals 0. But notice our sequence has a factorial in it. Doesn't change anything. Just got to do the math. But we are going to start with a 0 equals. So it's going to be 2 to the power of 0 divided by 0 factorial. Anything to the power of 0 is 1. 0 factorial is 1. In case you have forgotten, note 0 factorial is 1. So just know that. So we get 1 over 1, which is simply 1. Lost the problem. First 5 terms. All right, so A1. So now it's going to be 2 to the power of 1 over 1 factorial. 2 over 1, just simply 2. A subscript 2 is going to be 2 to the second power over 2 factorial. So 4 over 2, which is also in this case 2. A3 is 2 cubed over 3 factorial. 2 cubed, hopefully you know that is 8. 3 factorial was going to be 3 times 2 factorial, which we already calculated right there. It was 2, so 3 times 2 is 6. And we get a fraction. So A4 would be 2 to the 4th power over 4 factorial. So 16, again, just multiplying that answer right there times 4 would be the quickest way of doing 4 factorial. Simply 4 times 3 factorial. Both divisible by 8, so reduce this to be 2/3. And so the answer to this problem, the first 5 terms of this sequence would be 1, 2, 2, 4/3, 2/3, and my board quit writing. All right. Pausing while I wait for my smartboard to start working again. There we go. And there is our answer. And that was 10.1, the first one.